All right, I'm Michael Walker. I'm a graduate student at Vanderbilt University, my website and whatnot. So this talk is sort of an extension of an impromptu talk I gave last year about from basically hacking to academia. And I'm a big believer that a lot of the skill set, at least in computer science, I'll be precise. So in computer science and engineering and computer engineering and things along that line, there's a lot of overlap between the skill sets of like a maker, a hacker, or whatever, and what you would need to be able to do in academics. So here's a brief definition or outline, and I'll go through like the definitions of the term hack, because that might make things a little bit more clear of why I think this, and we'll get to some other stuff. Some of my academics and how the experiences I gained from different activities I've done throughout my life have helped provide backing and skill sets for what I am doing currently in my research. A little bit of explanation of the hacking that I've done at Youngstown and here in Nashville. Here's a little hint. I'm not actually that big of a hacker. I generally find issues and then be like, I didn't do it. I'm sorry. Please don't blame me. And then we'll talk a little bit about some of my research. Mainly, I'll cover blockchain, but I've done research on mobile for Android, model-based code generation, learning at scale. I'm the co-instructor on 4 or 5 Coursera courses on learning Android, so I have a wide range of different topics of interest. So first of all, let's talk about what the definition of the term hack. And this is sort of important in just of a mindset of how you approach things. So the verb definition, to cut, okay, we understand. To use a computer to gain unauthorized access to data in a system, which is what we're thinking of generally here. And informal, to manage or cope. Lots of people can't hack it type of thing. And then you have a noun. So a rough cut, blow, or stroke. And then informally, an act of computer hacking. A piece of computer code providing a quick or inelegant solution to a particular problem, or a strategy or technique for managing one's time or activities more efficiently. So A and B under noun are what actually are relevant to academics. And that might seem a little counterintuitive. In academics, you generally want to be rigorous with your research and rigorous in what you're doing. But that's not always exactly the real truth. Generally, you're rushing to get your research done in time to submit the paper to be able to publish. And so you generally are hacking code together, or mechanical engineering, hacking the solution, or whatever the case may be. Hacking your thing together quick enough and getting it to work so that you can publish in time for the conference or journal that you're targeting. And so the strategy for technique of like life hacker type stuff, that's a lot of us do that anyways. Oh, I'm going to spend 10 minutes writing this script and it'll save me an hour once every couple of months or whatever. Okay, then I'll write the script. Or it'll take 10 hours to write this script and I only use it once, I'm not going to bother writing the script. So a lot of sysadmin time management type of skills become useful when you're doing academic research. So first of all, you don't have as cool of a school as I do, because we have penguins and stormtroopers. So Youngstown State University is my undergraduate. I graduated Summa Cum Laude, a bachelor's in computer science with a math minor. I graduated in the honors program, which I actually took a course called Superman and the Superhero Construct. Honors programs are really good things if you can get into them early as a freshman, because they basically help you keep your GPA up. That's a little secret if they don't really tell you. And you don't have stormtroopers or penguins. Actually, I know you don't have penguins because it's the only Division AA school that has penguins, or AA, AAA, or single A. So a little bit, this is pulled off of my CV, basically a long resume. So I did a bunch of coursework, and before this I had learned programming at my high school. I taught at a summer camp. In 2006 I was working at a little, we'll just call it rinky-dink networking company that was providing internet to hotels. And so I went back to school and I took a bunch of programming courses. So programming, problem solving, operating systems, compiler design, lots of stuff like that. But I also took like Unix system administration, Unix environments, and a bunch of different information assurance. So things that you wouldn't necessarily associate with a computer science degree, that you would more associate with something in like an IT or a CIS degree, computer information systems. So that gave me a wide breadth of topics that I was somewhat familiar with from working in a networking company, but were somewhat useful at the time, but have since then become more useful because of the research I'll talk about. And why that's important is, at the time, I was still working full-time. And so if you're not familiar, full-time at a university is considered 12 to 16 credit hours. I was taking 12 credit hours a semester instead of the 16. So it took me roughly 5.5 years to get my bachelor's instead of the 4, because obviously I had more classes to take. So, like I said, I was in the honors program, and that mainly, the criteria for that is you get A's your first semester. It's not that hard. You just like, oh, okay, yeah, I'll sign up. And that was one of those little things that you don't really think is going to have a big impact, but it does. So doing it this way, taking less classes but slightly longer time, I have come to believe is a much better way, especially for people who consider themselves not necessarily strong academically, because you have the time to focus on the individual courses. And that was one of those concepts that I learned from the honors program. So I was in the ACM, Association for Computing Machinery. Some schools have strong ACM groups, some have strong LUGs, Linux user groups. My school had a strong ACM. I was a member for 4 years and president for 3. I did the Model UN as an honors course. Honors courses, you take a course regularly and you say to the professor, hey, I'd like to do some extra work and get honors credit for this. And what that did is it fulfilled the criteria for the honors program, but it also made you dive deeper into the material. And so you get to choose what courses you do that to. And so one was political science. And so I joined the Model UN for a little bit. And then there's just different honor societies. Let's see. Oh, well, this is it. That's old. Oops. I definitely got that. And so one of the things that doing this did, it gave me time to, I worked as a lab assistant at the university because sadly minimum wage was basically what I was making at my other job at the time. So sure, I'll work at the lab, I can do my homework there and be done. And that ended up resulting in me, who had years of actual work experience, tutoring people, which I was fine with. And that's basically, there's a direct line from me and getting involved in that and tutoring people to getting a full ride to Vanderbilt for my PhD. So how that happened is I got involved in doing undergraduate research. So, first of all, who here has a bachelor's, or who here is in or has taken some university courses? Okay, who has a bachelor's? Okay, who has a master's? Okay, PhD?
Not quite.
What?
Not quite.
Okay, so it's actually the requirements for undergraduate research, you would be surprised how easy it actually is. So one of the projects I worked on was in my group was, people remember, or at Berkeley, do you guys remember back when the notification of zombie cookies through Adobe popped up? Well, they were the ones who wrote the paper on that. So it wasn't that big. Another undergraduate research that some people did at YSU was they did network packet capture of the Xbox 360 and looked to see, is there anything in plain text that you can attack? No. Okay, that's the research paper. For an undergraduate, that's actually, if you follow through the steps and you document it and you do those types of things, that's publishable. So it's not like there's a huge, like, you don't have to solve is NP complete or anything like that, or some super math high level concept or anything. Oh, I solved distributed systems. You don't have to do any of that. You can do basic low level research that is what you might right now be doing, but just consider, oh, I'm just screwing around and doing whatever. I'm seeing if how this works. Profiling this thing, what does it do? So I did that. There's things called REUs, I'll describe that at the end. They're called Research Experience for Undergraduates. They're basically federal grants that you can apply for. And they give you room and board for 2 months at a university, flight there and back, and you do research with a professor and a graduate student. And basically, they teach you how to apply for grad school, basically, is what it boils down to. How to do research, what is expected, how to make a paper, how to make a poster, like the actual logistics of doing research. And if you're an undergraduate, you can apply for these. And you guys would be surprised. I was technically a diversity candidate as a white male because I was from Youngstown, which is an economically depressed area, and I was a first-generation college student. Because of the way that the federal government has changed criteria for diversity, it's diversity of viewpoints, not necessarily age, sex, gender, things like that, because they don't want to discriminate on those things either. So if you have a viewpoint or you have life experiences that set you apart from others, which I'm betting most of this room does, especially compared to most undergraduates, you would be able to apply for these things. But if you already have your bachelor's, maybe you are interested in other things, so we'll talk about that. I did a bunch of volunteer work, and I said how basically tutoring people led to me getting involved in undergraduate research. That led me to professors telling me, you should apply for this thing. You can go to Berkeley for the summer. Oh, okay. And then I went to Vanderbilt for a summer. Oh, okay. And then that's what led to me applying for Vanderbilt. So, I already have my master's of science in computer science from Vanderbilt. I work for the Institute for Software Integrated Systems. We don't talk about the acronym anymore. I don't know why, it's just a thing. I have a lanyard that says ISIS on it. I love taking that through airports, just seeing people's reaction. No, some of the focus areas I work on are software design patterns. My advisor was one of the first people who wrote the book on that. He's spoken here before, Doug Schmidt. You can watch the video on YouTube. Also Android, but not Android as a thing, but using mobile devices as our purpose of teaching, because we're teaching operating systems concepts. And inside Android, there's a lot of advanced topics that you can teach that we use to do. And I don't yet have my PhD. I would really hope to get that soon. Like I said, I taught some Coursera courses, and in here I'm going to talk about one of my most recent projects about blockchain. So before we continue on, we're about a quarter of the way through. Are there any questions so far, or comments, or anything that anybody wants to ask? I'll just stop here. The talk's somewhat segmented, so. It's basically just been me explaining my experiences so that we can talk now about how the different research things that I've done in the past apply to things that I'm going to be talking about. So, first of all, before we get into this, just show of hands, who actually understands blockchain? Okay, who hasn't heard of it? So Ethereum, Bitcoin, they're all blockchain. I'm sure everybody's heard of it at least. Okay. Who here has some sysadmin experience? Who doesn't? Okay. For the record, the majority of the room, everybody knew what blockchain was, and almost everybody had some level of experience with sysadmin. So, blockchain, let's just give a basic overview so that everybody actually really understands what it is. Blockchain isn't anything new in and of itself. What it is a using of different technologies combined together in a new and unique, novel way to provide a service. And that service is a distributed ledger. And so Bitcoin, Ethereum, Hyperledger, Dogecoin, however you spell it or pronounce it, Litecoin, etc., etc., etc. So, first of all, what's a ledger? Obviously, everybody in here at least knows what a checkbook is, even if you don't use it. But that's the basics of what a ledger is. It's just a sequential series of entries in a checkbook or a receipt, basically. And so what is a distributed ledger is obviously a distributed system that contains a bunch of copies of theoretically and ideally the exact same ledger. So you have a bunch of these ledgers floating around, and they, by magic of computer science and algorithms, eventually they all agree. So how does this actually work, and what are some issues in it that aren't apparent at first? So clients and accounts make transactions locally, and then they send these transactions to a miner. Now the miner takes these transactions, but they don't put the transactions, they put the transactions in an order. But what order those transactions go in inside a single block is basically random. So that has some implications that have some areas where we can do research, and I'll explain that here in a second. So the miner does the transactions, it mines them. Basically mining, if you're not familiar, is the miner is actually running these processes, these AKA short programs that will be stored on the ledger, and it is doing this in the hope of being able to be the first one to complete it and to put the transactions onto this distributed ledger in the hope of being able to make more currency for itself. There's some interesting talks about how parallel are transactions, or aren't they? Excuse me. So transactions are by design not parallel. But like everything in computers, that doesn't necessarily mean that you can't do them. You just have to know how to massage them. So transactions may or may not be natively parallel. Okay, and what does that mean? Or naively parallel, sorry. A plus A equals 1,000. Like these transactions here, these were written for undergraduates who didn't know anything about distributed systems or how to run things in parallel and whatnot. So they're very straightforward. So A plus A equals 1,000, A plus A equals 1,000. So like these can be run in parallel, but they might have issues depending on if you don't do them in time. Like the results of one impact the input of another. Whereas these are different. So you could definitely run one of these and one of these at the same time. But you come down here and you see B equals different values. So obviously which one of these comes first matters. And these are naively simple potential transactions. These will never show up in reality. If you've written your smart contract, which is the code that's supposed to run in the ledger, at least in Ethereum, at all well. Excuse me. So, excuse me. Yeah, we'll just go. So, now, how do you actually use Ethereum? Another show of hands. Who actually has ever ran Ethereum? Anybody? Okay, one guy in the back, and that's it. Okay. Just out of curiosity, how easy did you find it to use?
Extremely.
Okay. How were you on private network or on the public network?
Most of it's been on the test network.
Okay. Did you ever make your own network?
No, I haven't.
Okay. Did you actually make an app, a D app, or what's called a D app in it? Or okay. So let's go through what that actually means. So in Ethereum, its command line client, its main one is geth, and that is written in Go. There's a dichotomy of you have code that runs theoretically on the blockchain. That's called a smart contract in Ethereum. Other things call it chain code, whatever the case may be. And you write what are called D apps, so distributed apps. D apps is a combination of the code running on the blockchain and code running offline in clients to interact with the code on the blockchain, and well, the results of the code on the blockchain, more precisely. So an example of this would be, most straightforward would be similar to what Bitcoin does, and you can do transactions. So I write a smart contract. I say that people can do transactions and transfer credits. Not a big deal. I say everybody in this list starts off with 1 billion credits, and then we go from there. Realistically, that's not usable in the long run, but that's fine for this example. So you have the smart code on that can be ran against the ledger, and then you have code that interacts with that. So the code that interacts with it will actually run the transaction and generate the actual call to the blockchain to say, I want to, if I'm on this blockchain and I'm one of the users with credits, I want to transfer credits to another user. Okay, great. You run your code locally, it generates all the code that needs to be ran and submits that as a transaction. That transaction gets sent to a miner or miners, and when it's ran and mined into a completed transaction, that's when it actually is processed. So you have code that runs against the actual blockchain and code that like basically designs the calls and sends them up, and then eventually gets notified that the call was mined and notifies the user through GUI or an API call or whatever the case may be. Does that make sense to everybody? You have two different things. Does that make sense? Does anybody not understand that? No? Don't be afraid. Don't be ashamed if you don't. Might not understand it. Okay. So you have the distributed ledger, which is your bank account or checkbook that there's multiple copies. And you have, we'll say a simple transaction would be, I wanted to send you $10 or 10 credits, whatever the case may be. I would have local code that would generate that transaction for me. I would submit that to the miner, the person over there or machine over there, and the miner would run code on the smart contract, or that's in a smart contract that I've generated parameters for and called. So basically I'm making a method call in a class. So the class is the contract, the method is the method in it, and the parameters is my account, your account, and how much money. So it does that transaction. Then we both have clients on our machines that are looking for that transaction to be completed, and it will notify us once that transaction has been completed, and 6 more blocks have been added to the chain to notify us that it's not actually going to disappear on us. So I hope that's a better explanation. Does everybody understand that? All right. So we've gotten a basic understanding of what a blockchain is. That's very high level, and there's some little like, oh wait, what is this? Concurrency? It's designed not to have concurrency, but that's giving us a topic of, well, okay, great. Now, can we do research on this? Like, there's questions here. How do we do this? So, what I did is I wrote, I don't really hate this acronym, but it's a little weird. So it's called PLATABART. So Platform for Transactive IoT Blockchain Applications with Repeatable Testing. And basically what that means is I made a system, a platform, that allows for development of IoT applications that use blockchain. And if anybody has gone to that continuous integration talk here previously at the conference, you understand the idea of you want to test your application all the time. You want to be able to test it repeatedly. So, first of all, how do we make a platform like that? What do we target? Ethereum or possibly Hyperledger or whatever the case may be. So I was targeting Ethereum because at this point it's the largest blockchain network with a Turing-complete programming language. So Turing-complete means you can make real programs. Whereas Bitcoin is actually specifically designed to not allow you to write real programs in the smart contracts. They're designed to only allow you to do financial transactions. People have been creative and sort of gotten around that in certain ways, but realistically it's a much more limited subset of the features you would need for a full-featured programming language. So, I won't get too much into what Transactive IoT is, but basically think of it in the use case we tested was smart meters. And you have a cluster of smart meters that are communicating, and you can trade energy back and forth automatically between each other and not have to contact the energy company. So NES here in Nashville, so Nashville Electric Service. You wouldn't have to contact them. You would be able to trade electricity between your neighborhood. Obviously, you need smart meters that can do this. You need the physical infrastructure, you need batteries, you need transmission line, all of that nonsense. We're just going to assume that exists. And then eventually, if some company actually builds that, they could use the transactive energy concepts that we've developed. So we're using Ethereum, okay. I designed a domain-specific language which might sound complex, but when you see it, you'll actually know what it is. You just never have called it that, because I made it very simple domain-specific language. I made a command line tool, so it's a network manager. It's and so this is the network manager in particular, is where a lot of you could actually get your entry point or jump off point into doing research. Because who here knows how to program at any language for anything? Okay. So programming, I'm computer science, so everything is like I dream programming. I have fallen asleep into the Dragon Book of compilers more times than I want to admit, because that book puts you to sleep. Amazing book, authoritative, but wow. Anyways, so but the concepts I'm talking about are applicable to basically anything in the STEM field, probably. Math, maybe not so much, but nowadays math is computer science anyways for most people. So, or they use computers for data analysis of big data or whatever the case may be. For most things, I would assume. And then the actor pattern model, composition of parts, and middleware reapps. I'm not going to get too deep into those, especially the middleware. I'm not even going to cover that really. If you're not familiar with what a middleware is, it's basically a set of services that provide an API for you that handle things for you. And in this case, a reapps is a middleware specifically designed at Vanderbilt at ISIS to handle, I'll meet you at ISIS, and you just say that out in public, and you get weird looks. Anyways, reapps. It's a middleware to provide services such as network communication, timing, and a bunch of different other things like that. You can find the research papers on Google Scholar. It's quite easy if you're actually interested. But it's designed for IoT applications. So the actor model, just to give a brief overview, you probably understand this intuitively, you just have never seen the definition. You all know what a component is of a system. Well, the actor model is a mathematical way of saying this component can save its internal state, it can start other actors, and it can send messages. And that's it. If you design your entire system that way, you actually don't have to deal with distributed systems like concurrency and locking and all this other nonsense that is really nice. Because probably not many of you understand what the idea of locking and concurrency is. If you do, I'm sorry. But it's a higher level concept, basically, that some small percentage of computer science people have to understand. They write the things that everybody else uses and nobody else has to worry about. So that you write your application that actually does whatever you want it to do, and you use somebody else's library to handle the concurrency and all that nonsense. So we decided to use the actor model to do this. So here's what the actor model ends up giving you if you use it in the way we are. So the client for Ethereum is called Geth. And you have two different ways of communicating with Geth. One, you can install your DApp application. You can install the code that runs locally inside the application as like a command line parameter. Or you log into the program and tell it to load JavaScript files and to run those locally. I think that's personally silly and that shouldn't even support that. But I also don't like Node. Okay. So that's just personal opinion. Anyways, so the other way is to run the Geth client as basically a service. You run it and then you communicate with it through remote procedure calls or some type of API that has a couple options. We ended up using HTTP JSON for our communication with it. So you'll see here in this diagram, this black thick line between wrapper and geth in every instance here. Okay, so you'll see these ovals. These ovals are an actor. That's just whatever. You have your application. You have geth is another actor that is running inside this actor, and wrapper, which generally you think of wrapper goes around something. Well, all the functionality of the geth client is handled by wrapper, but it is separate and technically a different actor, because then we don't have to worry about concurrency in our model. So if we just stick to these basic rules, we don't have to worry about these other concepts. And so these are some of the basic things that you would learn in a junior level undergraduate computer science course about concurrency. If you want to watch them, Doug Schmidt's videos are free online on YouTube. Actually talks about this. So we see we have actors here. The actors have subcomponents that are other actors, and they all communicate with each other with these black lines. So those are the management APIs. That's the JSON passing back and forth through sort of a REST API, but not quite. It's just consider like a REST API. Then these clients, these geth clients, communicate through the squiggly line that's on blockchain. So they use a different mechanism to all communicate with each other. So if you start up a geth client and you don't do anything special, you can make it connect to the public network. The public network, you obviously don't have any money until you buy some, or mine some, or whatever the case may be. Extort Russian, or whatever. I'm not saying anything. You know. So that's the case for that. However, you can also create your own private blockchains that are good for testing. And that's where this is led to. So when you're developing an application, you want to test that your application works under different scenarios. And so you want to be able to spin up a test network and have them all communicating, have everything the way you expect automatically, and then be able to run your integration test against it and see if it works. And you want this repeatable over and over and over and over until the end of time for regression testing. Because let's say the new intern submits some code. Oh, okay, he's working on submodule A to BC, and for some reason that breaks submodule XYZ. Why? We have no idea. It's not a reasonable thing. It shouldn't have happened, but for some reason the library that he was calling had a weird dependency in it and things broke, or whatever the case may be, some extravagant reason. It's not even his fault. He makes a change, and if you don't do the regression testing, you don't catch that something else broke. But if you do the regression testing and you do continuous integration, you test, then you know this commit, for some reason, fault or not, breaks the code, and it breaks a test. Obviously, you have to have a continuous integration server, you have to have be able to run regression tests, you have to have somebody who's written regression tests and updated the regression tests as things have changed. But in a big company, these are the best practices. If you don't believe me, have fun doing it some other way. And can I record it? Let's see. Okay. So that's what the squiggly line is. It's the actual blockchain communication. And you'll see a dotted line here in the center. This is the off-blockchain communication. So let's take the transactive energy example again. Sorry, I backed away from the mic. Let's take the transactive energy example again for a second. If I am what we call a DSO, it doesn't matter what the acronym is, you can read the papers if you want, you won't care, most likely. I am the service operator. I am the electric company, basically. If I want to do a transaction in a different model, or somebody wants to do a transaction, they would communicate with me, get a account, I would give them an account with some credits on it, so therefore they can even submit a transaction. Because in Ethereum and most others, it actually costs money to even make a submission. So you can't just sign on to the network and be like, I'd like to buy something. Oh, I don't have money. So that's a catch-22 syndrome there. So you don't want to make every smart meter go be a miner. Because, oh wait, you don't want them using that much electricity. What is it, 70 gigs right now of Ethereum, or however big the full blockchain is. Obviously you don't want the miner having every smart meter, every smart device, a Raspberry Pi, or whatever the case of your small IoT device is. You don't want those being miners. Maybe you want them being clients and they'll interact with the blockchain, but the gas client is like 20 megs or something like that. It's relatively small, maybe 2 megs. I don't know, I forget offhand the exact size. But okay, it can run that. It can run my wrapper logic. It can run whatever, but I don't want it to do the mining. So you need to contact me off the blockchain to start up this transaction, to be able to get starting credits. And so that's what this off-blockchain communication is. And there's other examples of this where we're setting up encryption keys. If you are we'll just continue on the smart meter example. You're a smart meter, the technician is, or you're the person owning the smart meter, the technician's installing the smart meter. They are off the blockchain giving you an encryption key to install in the smart meter. Technically, that's not necessarily a directly electronic transaction, like they might have the smart key on their device and install it. But if you think of it as a full system, the key was generated somewhere by the electric company. It was given to the technician put it on your thing. So you can envision that how that is a networked transaction. So even if they're not directly communicating, there's still some mathematically communication. So if you account for that, even if it's extraneous, great. So I talked about how domain-specific language. Does this look familiar to anybody? Oh, look, it's JSON. Oh, look, it's a configuration file. That's it. Domain-specific languages can get much, much more complicated. You can literally get your PhD on them. I work with tons of people who did. Oh, well, that's weird. Anyways, the slides are reversed for this. So domain-specific language. You want to run your test network. You want to have a version number. Chain ID is a private number. Guess I can't click. Chain number or chain ID for Ethereum is the number of your private blockchain. So you can actually run multiple blockchains at the same time. As long as they have different numbers, they won't actually communicate with each other. So that's a nice mechanism if you want to do different testing on a data center type of thing. Difficulty is obviously how, I'll learn eventually. Difficulty is how hard you want the mining operation to be. The gas limit in Ethereum at least is how big of a transaction mathematically do you want to be able to provide support for. So how big of a smart contract can somebody upload, and how long computationally can the code that they're running, the program that they're running against the smart contract. You remember we talked about how there's code that runs on the smart contract. how long can that run for? And so that's what this gas limit is. And then balance is something that I wrote. It pre-gives every account 40 trillion quadrillion Ethereum, which if you had that, you could just buy the Earth if it was real. But in our test network, you can just give however much you want and be done with it. Some Genesis output file here, and then clients. And then clients are here. We're going to start at port 9000. We're going to have 15 of them, and they're going to be evenly distributed over those clients. So that actually makes somewhat sense. Here's my test network. Here's a version number. Here's some metadata about it. Here's stuff. And here's the clients I want to install. They're going to have a name, whether they be prosumer, consumer, DSO. Those are specifics to the paper we wrote, but they could be a mobile app, they could be smart meter, they could be house alarm, whatever your case may be that you're writing your program for. So now, obviously, you have a configuration file. What's the next thing you want to do? You need that configuration file to be fed into something to generate the test network. And this is really where I see the melding of the academics and the hacking perspective. So,
academics and what?
The hacking perspective. So this is just sysadmin stuff. I knew how to do some of this from just learning Unix command line and knowing Python, basically. So the program is stateless, which means it has no internal memory. Everything is from a command line argument. And the purpose of that is that it can be integrated into other programs. Those programs can keep track of where they're at, or the order of things, the calls to make. It's command line. It uses the Fabric API to allow, oh, wow, the mysterious thing that, let me tell you, almost no undergraduates know about, called SSH. I wish I was kidding. And then the click API, which is a Python API to allow nice command line arguments with help menus and display things nicely. So, yes?
Undergrads at MTSU have SSH, especially if they take a Dr. Butler class in SSH.
Well, yeah, undergraduates at Vanderbilt eventually get SSH too, but I remember it was literally the first thing we learned in our first programming course was how to SSH into the Homer or Frodo system, which was at my undergraduate the name of the CSIS department server, so you could work from home. They don't teach that early anymore because everybody has their laptop or whatever the case may be. Yeah. So, anyways, here's test to phase. It's 49 after, we got 10 minutes. I'll rush through these. It doesn't matter exactly what these phases are. So obviously you need to create miners, you need to make the blockchain configuration file, then you need to create the actual blockchain from that configuration file. You need to be able to distribute to miners, distribute to clients, create clients, make the full network, stop the network, make sure the clients are started, miners are started, delete the network, things like these. These are individual commands in the network manager. So I ran a bunch of tests, and this is where it becomes academic. And this is really the only difference between you sitting at home on your laptop in your basement or your office or wherever, and somebody publishing paper. One, they have criteria and they've learned how to publish papers. Two, they have criteria and they've learned how to publish papers. That's basically the difference. And so here, 2 prosumers, 5 prosumers, 10 prosumers, 15 and 20. Now, obviously that's not a huge scaling, but it is indicative of, we come down here and we run the numbers. I'm not going to get into them in particular, but conclusion, we run the numbers. Average time either remained static or scaled linearly with the number of clients. Well, what does that actually mean? These test phases scaled linearly, and these ones remained relatively static. Now you'll notice clients creating. Well, the more clients I'm going to create, the longer it's going to take. Distribute to clients, full network created, network connect, start the clients, and stop the network, where it connected to every individual client. So it makes sense that every individual client you connect to is going to take longer. But you come back here and you see clients create. For 20, it took 42 seconds total. Okay, I have an intuitive understanding as a sysadmin that it's going to take roughly 2 seconds, roughly, per client to create the client and the configuration and all that stuff. And you come down here and you can estimate how long each one of your tests is going to be depending on what parameters you make into it. And that's it, that's the paper. That got accepted. I'm going to Vegas this December to publish it at Middleware, which is a very well-respected academic conference. It's a workshop paper, which means it's not really fully complete and as something you would put in a journal or anything, but that's still a publishment, and that's all there is. So as hackers or makers or whatever, the difference is I have literally taken courses on how to write academic papers. I have learned how to write the paper and how to do the test analysis of how to do the math to do the results. But I'm only one of 4 co-authors on this paper. I have like 11, 14, something like that, I'll have to check, but on Google Scholar publications. On most of them, I've done sysadmin work, basically. What boils down to sysadmin work. Be like, oh, I know how to analyze these couple gigabytes of data and pull them into text parsing and run regex and use awk to rearrange them and then put them into CSV and then run them through R, which is a stats program. Okay, well, how many of you have had to do log analysis or have had to do something that sounds exactly the same and instead of it being data from image processing, it's data from a server running and you're looking at intrusion detection. They're basically the exact same skill sets. It's just how you're applying them. So, things behaved, scientifically timed, analyzed, etc., how we expected them to. Yay. That's basically all there is to it. You have to be rigorous, you have to be careful, you have to therefore then write a good paper explaining why you did what you did and how you did it. But that's basically it. You can, even if you don't like academics or you don't consider yourself good at school, just take a single course. Go on Coursera, go on edX, go on one of these things, take one of the courses for free, learn how to write an academic paper, take an editing course for technical and professional editing. That will teach you a lot of this stuff. Learn LaTeX, LaTeX. Looks like latex, or latex, but it's pronounced LaTeX. It's a programming language basically for publishing papers. So here's the paper I wrote. You can scan through it. It's the ACM standards and references and all this other stuff. This was written in a text editor. Actually, overleaf.com. It's a website that does this stuff for you. But it's just text editor. You run it through the program. It makes all these nice diagrams and tables and everything for you.
Is it Overleaf?
Mm-hmm. I wouldn't recommend, well, don't dive into LaTeX without understanding what you're doing, because it's an archaic thing. So definitely research what you're doing. But anyways, back to the presentation. It works. Now, we got 5 minutes left. I'll talk about the research and how to do this for fun, which we've done already, fun, or profit. So in profit, this means funding. So first of all, research experience for undergraduates. I can't talk about this enough. So as an undergraduate, you get $4 grand basically for living expenses. You move to wherever the university is. They pay for your room and board, so you just have $4 grand extra for whatever, and you get it to build your resume and your whatever, and you are taught how to do these things. In particular, through the NSF one at least, you have to take a course through Kaplan, which teaches you how to do, at least some of them, teaches you how to take the GRE, which is essentially the graduate level equivalent of the SAT or ACT. And it teaches you the basically tricks. Those tests are designed to test how well you can take tests. So it teaches you the strategies for being able to pass that test. So the verbal, the math, and all of that stuff. Then, so the NSF, the DOD, the DOE, the DOE, so Department of Energy, Department of Education, the Department of Agriculture, I think, and all the other big departments. At least they used to offer. I don't know anymore. I'm not going to say anything. But they all offered research experience for undergraduates. You can look at individual universities and see what they're offering. Vanderbilt here offers them, well, here in Nashville, offers them for certain, the med school offers them, I think biology offers them, independent from the rest of the, like these types of things. There's scholarships, there's grants, there's grad school. Like I got a full ride to Vanderbilt because of having the work experience with faculty members, that they were willing to spend the funding that they had on paying for my tuition and whatnot for me to contribute to their research. So that's how a full ride works, basically. You are an indentured servant, but I guess that's better than a slave? I don't know, whatever. And conference trips. Yeah, like technically this trip I'm getting reimbursed for because I have a $600 extra credit that I got from teaching some courses over the summer. So, okay, it's going to pay for my conference hotel room and my food and room and board and the 35-minute car trip on by car. So, there we go. That's basically the end of the talk, and my time's up. Feel free to hit me up individually if you have any further questions. I went along a bunch of stuff. I really honestly do think that a lot of the skill sets that people learn individually are applicable in academics. The only difference is, as makers, hackers, whatever, we learn a very broad range of topics. But in academics, we learn a very narrow range of topics, but very deep. And in us, and hackers and makers, we learn a very broad and then very shallow on most of it. Like, oh yeah, I sort of understand LDAP. I did it once. I did. I did it once. I could look it up and I understand the concepts, sort of. I sort of understand information assurance enough to not mess things up. I'm actually pretty good at database design. I can make a programming language, so those are my deep areas. You might be a network manager, you might be a sysadmin, you might be a whatever, a data analytics expert. Whatever the case may be, we all have our deep areas and our broad areas. You guys have a much broader range of experiences than most undergraduates and, to be honest, graduate students. So if you can figure out how to leverage that broader range of experiences, you're actually in a better situation than a lot of people. And it's just, can you put up with what a lot of people consider the BS of undergraduate going through the coursework? My recommendation for that is take less courses at a time. It might technically cost more in the long run, but you can work full time and then take a course or two, or do whatever. And nowadays, There's my former roommate and a current Vanderbilt graduate student. He got a full ride to Vanderbilt because he took a Coursera course that one of my advisor taught, and he was in the top 10 worldwide. And then he asked the professor, is there any opportunities for coming to the US to do research? So he came for a summer, he did an REU, he got paid, he lived here for the summer, he did his research, he proved himself, and then he got offered admissions. So he's here now, and he's literally the first person in India from his province, which amazed me, that to come to the US, at least from his school, which is the main school in that province, to come here to the US. So online education, these MOOCs, massively open online courses, so edX, Coursera, whatever, there's probably others. They're not bad. Get your certifications, pay the $50, be like, yeah, I actually did this. Build up your resume, and then blind email a professor that's doing research that you're interested in. Go on Google Scholar, which is a free site, and Google whatever topic you're interested in. Blockchain, distributed systems, BitTorrent, whatever. Read some papers, and if there's anybody who's doing research that you're interested in, just email them, ask them. Do you have, and then look through some of their other research. These aren't really tricks, but a lot of people don't think that they're necessarily qualified. I work with a lot of people who have bachelors or masters who are doing research for their companies that's just what they do. So if you're interested in doing more academic, more actual scientific rigorous work, then you'll be able to do what you want. I think we'll stop here. I'll be up here for a little bit. If anybody wants to ask an individual question, I'll be at the con the rest of the weekend. Feel free to ask me any questions you want. Is there any, raise your hands if you have a question you want to ask.
Can you put your contact on there? Email, Twitter, whatever?
Yeah, there's my Twitter and my website. All right, that should be it. Thank you, everyone.